Hi students, in today's session we are going to discuss about electron guns. We learnt in our previous video class that the electron microscopes use electron guns to emit electron beams. That is, these electron guns are electron sources which emit the electron beams. If the beam of electrons are produced thermionically, that is by heating, then the electron gun is called thermionic gun. Here I have shown you a schematic diagram of the thermionic electron gun. This diagram has been taken from our book of study, that is Introduction to Nanoscience and Nanotechnology by K.K. Chadobadhyaya and A.N. Banerjee. In a thermionic gun, firstly there is a filament. Usually the filament is made of either tungsten or lanthanum hexaboride LaB6 cathode. This is the cathode. The filament is the cathode. And the electrons emitted from here are accelerated towards an anode. So let us see the explanation about the working of a thermionic electron gun based on this figure. Firstly, we have the filament here, which is given a negative potential, that is, it's our cathode. The filament made either of tungsten or lanthanum hexaboride, which is a solid state crystal. When this filament is heated, electrons get emitted and they move towards the anode plate, which has been given a positive bias. But before reaching the anode, the electrons see something called a Van 't cap. This is called the Van 't cap. Now the Van 't cap is given a negative bias of about 500 volt. Now the electrons emitted from the filament moving towards the anode now sees this negative electrical potential and they get repelled by the Van 't cap. That is, the electrons which has been emitted from the filament in all directions now form a collection between the filament tip and the Van 't cap. അതായത് ഫിലമെൻറ്റിൽ നിന്ന് എല്ലാ ഡയറക്ഷനിലേക്കും എമിറ്റ് ചെയ്യപ്പെട്ട ഇലക്ട്രോൺസ് ഈ Van 't ക്യാപ്പിൽ നിന്ന് റിപ്പൽ ചെയ്ത് അവരൊരു കൂട്ടമായി നിൽക്കും ഈ ഫിലമെൻറ്റിൻ്റെയും Van 't ക്യാപ്പിൻ്റെയും ഇടയിൽ. Some kind of focusing is taking place. Okay. So what is happening? The electrons emitted from the filament, they try to move towards the positive bias at the anode plate. That is, they are getting accelerated towards that direction. But on the way, they meet the negative potential applied to the Van 't cap. So they get repelled. And all the electrons coming in different direction gets repelled and they form a collection called space charge between the filament tip and the Van 't cap. The electrons at the bottom of the space charge region can now exit the gun area. This is the gun area. They can exit or come out of the gun area by a small opening here in the Van 't cap. Okay, so what is happening? Because of the negative bias given to the Van 't cap, the electrons get collected in a particular region called the space charge region. And this, out of the space charge, the electrons accumulated in the space charge region, those at the lower end here, what will happen? They will pass through the hole made in the Van 't cap. And they, after they escape through this hole, they are accelerated towards the anode. And the electron beam moves down and they are used for imaging. So this is the first technique by which electrons are produced, used by means of thermionic emission or using a thermionic electron gun. Now the second method for the production of electrons is by field emission. This is the second type. That is, a field emission source or a cold cathode field emitter where the filament is not heated is used here. Again, the filament used is tungsten itself, and the tungsten filament is made into a very sharp tip. Whereas in the earlier case, our filament, that is in the case of thermionic emission, the filament did not have any sharp tip here. Whereas in the field emission case, here the electrons are emitted by field emission, then the filament tip is made very, very sharp. And a large field is applied across this filament. What happens here is a strong electric field gets concentrated at the small tip so that the electric field becomes very large and electron emission takes place. So this is a field emission type of electron gun. In a field emission type of electron gun, what is happening? The filament is made in such a way that it has a sharp pointed tip. And a strong electric field greater than 2 kilovolt is used, and it is concentrated to this sharp tip so that the field becomes very large and electron emission takes place. So I hope both the ways in which electron emission takes place, or the two types of electron guns, one based on thermionic emission and the other one based on field emission, is clear to all of you. If you have any doubts, please do contact. Thank you.